Good afternoon, good morning, or good evening, depending on where you are in this world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon. I'm the moderator for today's event, and we have a really great one on tap. Before we get started, though, we do have a few housekeeping items I'd like to go over. First of all, today's webinar is being recorded, so if you miss any or all of today's event, just know that you'll be able to access it on demand after the event. We'll be sending out a link by email that you can access the event. It'll also be on the DevOps.com website. And we are taking questions from the audience today. So if you have a question for our panelists at any time during the event, feel free to use the control panel to submit your question, and then we'll take a few minutes after the actual presentation to go over the audience questions. Okay, with that, I would like to dive right on into today's webinar, Shift Left Security, What, Why, and How. Our speaker today is Joshua Thorngren, who is VP of Marketing at Twistlock. Josh, thanks for joining me today.
Thanks for having me, Charlene. It's a pleasure to be here. And thanks for everyone who's on the line listening in. I hope you find it both useful and enjoyable.
All right, well, I'm just going to go ahead and turn it right over to you and let you do your thing.
Sounds good. So before we get started, I just want to briefly give an introduction to who I am and where I'm coming from, as well as Twistlock, the company. And I'll keep it brief. My intention is not for this to be marketing content in any way. So I'm the VP Marketing over here at Twistlock. I come from a wide range of roles, primarily on the DevOps side of marketing. So how to evangelize for DevOps companies and how to help customers solve their DevOps challenges. Once upon a time, before that term had ever been coined, I actually ran operations for a development team 12 years back. So while I'm been away from that world for a while, I do like to think that I'm slightly more savvy on these issues from the modern marketer. But I will say this, I am still a marketer. If you're coming here today expecting to see in-depth technical content, I can only offer you my apologies. That's me. So let's talk about Twistlock. We're a cloud-native cybersecurity platform. What that means is we protect modern applications, containers, serverless, any other new modern ways to develop and deliver applications. We offer an automated, comprehensive platform for protecting them. So getting that out of the way, let's talk about what we're going to hear today. We're going to cover a few different topics today. What is shift left security? We'll attempt to define this term in a way that is both concrete and also gets to the goals behind the terminology. At the same time, why is it important? And these two aren't going to be in this crisp of order. To really get into what shift left security is, we have to talk about why it's something people even care about. Once we've done that, though, we'll talk about how do you, as a developer, as a DevOps engineer, as a security operator at your organization, how do you help enable shift left security? If time permits, we'll finish out the session today with question and answers. So let's get started. I'm going to begin by setting the stage for why we even are having this discussion and why shift left security is a thing that matters. If you think about the world today, there are two opposing trends. One is internally driven and one is externally driven. Let's start with the first. Software is eating the world. And I know what you're thinking. Every org becoming a software organization. That's marketing gobbledygook. But it's also the truth. Today, software applications are the transaction layer that powers the world. It's how we order food. It's how our cars navigate. It powers the watches on our wrists. It powers the business applications that it has for years as well. The value that a company can deliver to its customers is increasingly more and more dependent on that company's ability to deliver software in a rapid and consistent fashion. To do so, software organizations need modern tools. It's modern tools, modern practices. DevOps, containers, other cloud-native technologies, these are the tools that we see adopted time and time again in order to help deliver that value faster. So that's one trend. The other trend is that the world is getting dangerous. It used to be that hackers were technically savvy, sophisticated actors who often had the backing of much larger powers. Nowadays, it's easy to launch an attack. Attacks have been democratized. You can buy hacking kits on the dark web. At the same time, security teams are overloaded. The rate that we've talked about over here of software moving faster and faster, that rate of change has only increased. And security teams have struggled to keep up with that. At the same time, as we've shifted more and more of our software infrastructure to large cloud providers, the applications that we all create at our own organizations become the softest target. And I want to be clear here. I don't mean for that the world is dangerous trend to come across as FUD. You know, I know it's very typical for a security vendor to spread fear, uncertainty, and doubt. I actually believe, and Twistlock actually believes, you can make the world a safer place today than you've ever been able to before. But you can't ignore the fact that the rate, the complexity, and the scale of attacks today is greater than it ever has been. And it's difficult for security teams to keep up. So let's be aware of that, but let's not be scared by that. So with this as the background, I want to highlight something about most organizations today. And that's only 20% of organizations that are following DevOps practices are integrating security into the development process. This is a survey HPE did last year. And what they found was that organizations make the shift to DevOps, to shipping applications faster, to being agile, to using microservices versus monoliths, but they don't make a similar shift with security. And this is challenging for a few different reasons. Why it's challenging, I think it's highlighted with this next slide. This came from some data Chef had. Only 15% of organizations can remediate security vulnerabilities or address compliance violations as they arise within a day. Most organizations take days, weeks, months to address issues found in production. So you think about that. Organizations are moving faster than ever before, but they're not shifting their security left, as it were. And organizations aren't able to quickly remediate issues that they find in production. So you're faced with this new world where when issues arise, security issues that are found in production, they have to be prioritized against the business needs of your DevOps teams. And their business is getting applications in the hands of customers faster. It's hard for security to win that battle until there's an attack. Once there's an attack, it's security's heads who often roll. And that's an unfortunate state of events. And it's that shift left security attempts to resolve. So let's talk a little bit about what shift left security is. It's moving security practices left into the software development lifecycle. And you do this to shift from a reactive to a proactive security posture. So you often hear a lot of talk around shift left security as, well, you know, that's testing before you deploy. Or, well, that's, you know, understanding your compliance posture when you build. It's a bit more than that. It's not just moving some of those checkpoints left. It's moving the whole security practice leftward so that you're defining requirements, you're testing and checking code and applications, and you're actually taking action on your deployment process, your build process, based on what you find in your security analysis. That's the true dream of shift left security, so that your security team isn't seeing code for the first time once it's already been built. They're seeing code for the first time when developers are ready to check it into a repo. They're seeing code for the first time, maybe even in tandem with developers, in code reviews or in scrums. At the same time, developers aren't hearing about security requirements after they've already built and shipped code. They're hearing about security requirements when they gather requirements for their applications, when they choose what features come out of backlog and are included in a sprint. That's what shift left security really is. It's integrating the practice of security in all its forms into the development lifecycle, even at the earliest stages. So if you've been around the DevOps movement at all, 10 years ago, we were talking about something very similar with IT operations. And for those of you who are in organizations that have made that shift to DevOps, you hear this and you say, well, we did it with DevOps. I'm sure we can do it with security. And yeah, you can. But unfortunately, it's not that simple. Traditional security practices are manual, time-consuming, and one more thing that I didn't actually add on here, they're often perimeter-focused as well. The traditional security role is, let me define a manual policy for this application I have in front of me, and let me enforce that in my security tools. It doesn't concern itself with what are the risk factors in the code itself. It doesn't concern itself with how do I automate this process, or how can I use a machine to understand application behavior and security risks. It's a security expertise and manual policy creation practice. The second piece, and I may go off on a small little rant on this one, and I do apologize in advance. Developers in security have very different domain expertise. I remember this was, some 15 years ago. I was a young computer science student, and I was very surprised that all we learned to do was code. We didn't learn how to then run those applications, or how best to protect those applications, or to code with security or efficiency of operations in mind. You learned how to code. And yes, that included coding in elegant, processor-friendly ways, but you didn't talk about the business implications of the code you wrote. And throughout my career, I don't know, I just sort of assumed that that was something that had been resolved or addressed. But I was reading a survey Cloud Passage did the other day, and the survey data was a couple years old, but still, they examined the top 50 computer science programs in the United States and found that only 3 of them required security courses for graduates to earn a diploma. Only 3 of the top 50. So you think about that for a second. Developers aren't being trained in basic security principles. They learn how to be the best at delivering applications, but not necessarily delivering secure applications. At the same time, security, it's not their job to ensure that developers can deliver applications. It's their job to ensure that data isn't lost to attackers. Attackers don't penetrate the system. Security is concerned with how do we stop attacks, not how do we deliver value. So that makes it difficult when you try to integrate not just security testing, but security practices into your dev lifecycle. The third piece here is that if you think about the ways security tooling surfaces information, it's difficult for security tools to give that information back to developers without developers having to go get that. There are some things that work well, but the ideal state is you're centralized on a tool itself. So let's talk a little bit about how you can work on shift left security. And there are a few principles that I want to talk about that help address some of those concerns and risks that we just covered. And then there's also one sort of supercharged trick that I think really helps organizations adopt shift left security at scale. And we'll go into that after we talk through some of these key principles. So the first one is security by design. Establish criteria up front. You often hear about this in the context of new compliance and privacy laws, privacy by design, but it's important to talk about security by design. If you have a team building an application, that team needs to have requirements on how to secure that application and what acceptable levels of risk are. That needs to be communicated when requirements are being scoped. If security is coming in midway through the build, if security is coming in after code has already been deployed to staging and saying, here's how this needs to be protected, that's too late. We think about developers wanting to deliver faster than ever before. The way you enable that is by ensuring they have all the requirements up front. So security needs to be designed into every application that's built. It doesn't need to be added on later. The second piece here, automate, automate, automate. And I cannot stress this enough. If you do not automate the way you deliver software and the way you deliver security, you cannot fully shift security left in a successful way. Let's talk about that automation though, because a lot of times people think, well, I've automated scanning for vulnerabilities, so I think I'm good. But think back to that statement around 15% of organizations have issues with addressing vulnerabilities or compliance violations that arise in production, or only 15% can do that within a day, apologies. It is difficult to fix code that has made it to production. That said, new CVEs, new risks arise every day. So it's not just automating up front, automating, as you kick off a build, scanning for vulnerabilities or compliance issues. It's in production. How do you automate checking for new issues as they arise? That's just as important as automating at the start. You have to automate throughout the entire life cycle. The third thing, and this seems counterintuitive a lot of times, control gates, they're your friend. A lot of developers think about having a gate or a blocking motion owned by security as something that slows down development. And it can, but it doesn't slow down development as much as letting something get all the way through to production and then having to go fix it because there were issues that weren't caught. The best way to do this is to integrate these gates into the tools developers already use, and to block code from ever being built, ever being integrated, if it doesn't meet the necessary security requirements. If you find vulnerabilities that are above your organization's threshold, if you find compliance violations for an application that has stringent requirements, that shouldn't be integrated into your code base. That should be stopped before the developer has a chance to move forward or hand it off. You need to have those blocking motions instrumented into the software development lifecycle and shift security left by shifting those checkpoints left. And this brings me to the fourth piece. You have to share tooling. The reason developers don't like control gates is far too often the control gate has been security saying, we found 20 violations, here's an email summary, or passing that information in some ad hoc way. The dream state here is a developer says, well, I'm going to kick off a build, and they go into Jenkins or something. And Jenkins instantly spits back out to them, sorry, you have 4 compliance violations here, please address, and shows them where in their code those occur and links them out to recommended remediation. You have to share tooling. Developers have to be able to use the same tools they use to deliver software to understand the security posture of software. If you maintain separate tool sets, you're placing a burden on developers to care about security. And again, it's not the developer's job to care about security, but if they don't, then security isn't doing their job. And so the best thing that anyone who's involved in application security can do is find a way to surface information to developers throughout the lifecycle in the tools developers themselves use. That brings me to my fifth one. We've talked a lot about shifting left and checking for compliance issues, checking for vulnerabilities, understanding applications. One of the things that needs to come out of shift left security isn't just how do we do all of that throughout the software development lifecycle, it's how do we capitalize on that for better protection once my applications are running. And I know that sounds a bit nebulous right now, and There's a reason for that. I have a very opinionated philosophy on this, and it's something I think Twistlock does well. I'll talk about that at the end of this. What I'll leave us for right now is with shift left, security has an opportunity to collect significantly more information about applications throughout their lifecycle pre-production. That is information security needs to leverage to deliver better protection. And if you don't do that, you're not recognizing the full benefits of shift left security. So those are sort of 5 principles of how to start adopting shift left security, 5 things to keep in mind as you start thinking about how can my organization move security leftwards into the development process. But there's another piece as well. And this other piece, it's kind of interesting. And I'll actually just bring this up and then talk through it a bit. Containers empower security teams. With containers, you can shift left more successfully than with traditional architecture. I was talking to a CISO at a financial services firm a couple weeks back, and we were talking about what they were doing for securing their Docker installation. And he said to me, listen, that's 15% of my infrastructure right now. What I'm really worried about is we adopted agile practices 2 years ago, and I still don't have a way to have my team review code before it goes out to staging. And if it's already deployed to staging, that takes up ops team time, that takes up more time than if we caught issues and addressed them before. So here's the CISO who's worried about, well, how do I make sure that I'm shifting left? And what I said to him, hey, that's right. That's the right thing to be concerned about. You shouldn't be worrying about, well, how do I secure my containers if you haven't shifted left in your traditional infrastructure, and that's 85% of your infrastructure. But the challenge is traditional applications, traditional ways of delivering applications are much more difficult for security teams to test and assess than containerized applications. And there are a few reasons that containerized applications are so much more security friendly, and a few reasons that they really help security teams do their job better in less time. If you've seen anything that Twistlock has presented over the past year or so, you've probably seen what I'm going to share next. It's one of these things that we really want to hammer home. There's a lot of fear around containers, a lot of worries that, well, isn't that a black box for security? Well, what should I do with containers? I don't know. Containers are the way in which you can be more secure. The benefits of containers are why, when I shared that slide out earlier, I said, listen, this isn't about FUD. This isn't about fear. You're actually better off in today's world. And that's because of these benefits. So apologies if you've seen this already. I can't hammer it home enough though. Containers have a few key characteristics. First, they're minimal. Unlike a traditional monolithic VM, containers are single purpose entities. It's easy to understand this is the thing a container does. Not this is one of 20 things a container does. This is the thing it does. They're declarative. Because of the way containers are layered, that makes it easy for them to be machine readable. And that has a bunch of implications in how you can automate security. We'll get to those in a second. The third piece is containers are predictable. Containers, if they're behaving in some way that they haven't been through their entire life cycle, that's anomalous behavior. That's someone trying to violate the immutability of a container, or that's an active threat. So you have a certain guarantee of expected behavior for containers that helps, again, with the creation and maintenance of security policies. So let's dive a little deeper on each of these. The minimal nature of containers, it simplifies security requirements. You're not building a security policy that covers an entire VM. You're building a security policy that covers a single-use container, a single-purpose container. The declarative nature allows automated analysis of vulnerabilities and compliance much easier. One of the things that I think is really powerful that Twistlock does, and apologies for getting too into the product here, but we actually offer, if you're running containers, per layer analysis of vulnerability and compliance data and pipe that right back to developers. So it's not, these are issues that were found in the code. It's here's the exact layer where these were found. Here's how you can remediate those. That type of fully automated vulnerability and compliance detection simply wasn't possible at scale with traditional architecture, and it is with containers. The third piece, the predictable nature simplifies automation of policy creation and automation of enforcement. So if you have a baseline of expected behavior, it's a lot easier to automate a security policy around it than if you're constantly looking for, well, what will this VM look like when it's patched? Okay, well, this VM just spawned a new process out. That's just something in the operating system. Okay. With containers, the predictability allows for easier security policy creation. So I know I just kind of pivoted a bit from here's shift left security to here's containers, but let's talk about why. When we think about establishing criteria up front, security by design, that minimalistic nature makes it very easy to establish criteria for individual containers or bits of an application and combine those into holistic security criteria. The automation, we talked about how the machine readable nature and the predictability allow automation of upstream, left shifted security scanning for vulnerabilities and compliance, as well as protection at runtime. Control gates, you know, there's not a ton there that directly correlates. We can talk about how you can make this happen though in a second. Same with shared tooling. Containers don't by virtue of themselves allow developers and security to share tooling. Again, there are some ways that this can be instrumented that I'll get to shortly. And then using dev learns for better production protection. When you think about all that scanning you're doing on containers, the simplicity and the automation of it, and you think about that predictability, those all combine to, as code is written, as code is built, already give you the workings of a security manifest, a security policy that can then be enforced. So I'm not saying containers are a silver bullet or anything like that, but they're definitely a shortcut to these three highlighted shift left security principles. You can do them without containers, but they're a lot faster and they're a lot simpler to do in organizations that run containers. So thinking back to that conversation I was having the other day, my message back was, listen, we are actually in a state where it's the role of a CISO to actually evangelize for containers and to say, we should be using these containers, these cloud native technologies to deliver software. Doing so makes us more secure. And I think that's a hard shift for a lot of folks in the industry because traditionally security hasn't owned making infrastructure, making architecture recommendations like that. But we're lucky enough to be at a point in the industry where the new way of delivering applications conveys so many security benefits and makes so many of these security challenges that we face much easier to overcome. So that's why I urge everyone who's involved in trying to shift security left to think about how can I do this for my container teams? How can I shift security left and also adapt cloud native architectures? If you can do that, you're going to be a lot more successful at moving security across your entire lifecycle. And so I'm going to talk a little bit about Twistlock now. I can't not. I apologize to everyone, but I'm a marketer. So we've actually built a platform that is, by just virtue of what it does, fully left shifted. So Twistlock covers security from the minute code is first written all the way through to as code is run and deployed. We talked earlier about building in control gates early on in the process. Well, with Twistlock, your vulnerability and compliance policies can act as control gates at any point throughout the build and ship process. If a developer kicks off a build, to use that Jenkins example I mentioned earlier, Twistlock can block that build and surface information back in Jenkins or any other CI tool to a developer in an fully automated fashion, ensuring that code that has risks doesn't progress further down the pipeline. If new CVEs are discovered in running applications, Twistlock can notify the developer who is responsible for those applications, is responsible for the builds that led to those deployed containers, those deployed applications. And we can do the same thing with compliance. The really, really powerful thing, though, is because Twistlock is a shift left security product, because we integrate into developer funnels, developer pipelines, and understand applications at an early stage, we're able to do some things at a later stage as well. And what that looks like is automated policy creation and enforcement for every application at every build. So Twistlock offers automated runtime protection for your applications and automated firewall rules, layer 3 and layer 7, that are deployed with each build. We learn about your applications when they're built and as they're shipped, and then we apply machine learning on top of that to protect them as they run. These are whitelist-based policies, and again, that's something that's possible because we start learning about the application early. Traditional security is about how do I create a list of known threats and block against those. If you're understanding how applications are built and developed, your security tool, your security platform can actually focus on how do I create a comprehensive model of how this application behaves and enforce on that versus trying to block every bad actor in the world and playing a constant game of catch up. And that's what's really powerful. And this is something that we can do at Twistlock because we are shifted left. And this is something that your organizations can start to do better, even if you're not using a platform like Twistlock, even if you're still manually deploying security policies at runtime. By having security teams understand application architecture and application structure early on, that gives them a leg up on protecting applications later. What the dream state looks like is where shift left shifts protection right. You use static analysis throughout the pipeline, and you use machine learning to build a predictive model of how applications behave. You add that to the traditional threat intelligence that security teams have always leveraged, and all of that together equals automated defense and protection. That's the shift left to dream. That's what Twistlock offers today. That's about as much as I'll say on terms of the product side, though. I don't want this to be quite a sales pitch. With that, I'd like to turn it over to anyone in the audience who might have questions.
Yes, now is the time. We've gotten a couple questions in so far, but we have plenty of time. If you guys have any questions for Josh, just use that control panel, submit your questions, and hopefully we'll have enough time to get to everybody's questions. Okay, Josh, if you're ready for questions, I'll start throwing them at you.
Let's go for it.
All right, great. The first one is from Keith, who asks, can or should you use automation to simulate security threats in stage and production?
You know, I think anywhere you can use automation, you should. The thing about, running penetration tests or simulating threats is automation is really, really powerful at simulating 99% of threats out there. It's very important to have that to make sure your applications are going to be defended against modern threats. What I will say, as someone who, again, in another life, was slightly involved with software quality assurance, it's the same principle. You automate as much as you can, but you still, if you're trying to do penetration testing, if you're trying to simulate attacks, yes, automate it. It's still always worth, doesn't have to be every single build, but it's always worth having someone with a devious mind and a good set of hacking skills going at your applications, trying to find holes that your automation isn't going to cover, that your automated tests aren't going to cover.
Okay, great. Next question. Do you think dev teams need to have security focused or security only dev resources?
The short answer is yes. The long answer, and if you think back to that Cloud Passage survey I cited earlier, it's difficult for dev teams to find security-focused developers. And embedding a security operations person on a dev team often doesn't make sense because their core objectives are very different. But if you can't have a dedicated resource, one thing you can do is, in each sprint, one dev on the team is tasked with all the security tickets, all the security items to do. And that works well. So if you can't find a dedicated resource, rotate through your team members. Get each of them exposed in turn to security challenges and how to solve those early on in the pipeline. And that, it helps train up developers who are more security minded, and it helps get you to that fully shifted left world where developers themselves can resolve security issues before they're flagged by a security operations team later.
All right then. Okay, next question. Let's see. You're pretty bullish that containers help shift left security, but aren't containers more of a black box than not for security teams? Interesting question.
So this is something we seem to go through phases of hearing a lot about at Twistlock, this notion that containers have shifted the way organizations secure and protect applications, and not for the better. And I think it's caused by a bit of a misperception on really what containers bring to the table. And why I think so is a lot of folks said, okay, well, I'm going to shift to containers. I'm going to use a new way of building applications with Docker. I'm going to use a new way of orchestrating my applications with Kubernetes. I'm going to use a new way of enforcing networking with Weave or Calico. And then I'm going to use my traditional security tools and expect it to work the same. And I think that's a little bit, I think that does containers a little bit of a disservice. They are a sea change in how applications are brought to market. And a lot of traditional security tools, that's right, they don't have the ability to look at what's in a container and to really understand what's happening, what processes are running, what syscalls are being fired off, what the networking connectivity is. And so it's easy sometimes for people to say, well, containers are a black box. But there's also a huge new crop of tools for monitoring containers, for securing containers, for enforcing networking policies with containers. There are so many products out there today that focus on how do you solve these challenges for containers. And then there are products like Twistlock who focus on how do you solve this challenge not only for containers, but also for any modern application. And so to people who say, aren't containers a bit of a black box? I guess my answer is, if you don't shift the tools you're using, yes, but there's no reason they should be. And the visibility you get in containers when using modern monitoring tools, using modern security tools, it's significantly higher than what you got in traditional monolithic applications.
All righty, great. So let's take a look at some more questions. We're getting some really good ones in, but it's not too late. If you do have a question for Josh, please just go ahead and submit it using the control panel. Easy for me to say. Okay, Marta is asking, we don't use Linux. Is this still something that we can accomplish?
So what I will start with is a lot of tools out there start with, well, how do we support Linux? I spent many years before Twistlock over at Puppet. And at first it was, well, how do we come out the gate and work on Linux? And then we'll deal with everything else out there. So there is this mentality that a lot of vendors in the market have, which is anything that's not Linux is a second-class citizen. But I think we all know instinctively that's not true. And one of the guiding principles that we have at Twistlock, not just from a product standpoint, but from a philosophy standpoint, is that security needs to be entirely agnostic of what operating system, what environment you use. So, for example, we have, on par Windows support and Linux support in our own product. A lot of other vendors are starting to make that move too. So I can't say to you, listen, you're going to find perfect parity for all the different tools that can help automate security checks and automate your CI process and automate deployment. I can tell you that we here at Twistlock have that. And I can also tell you that a lot of this is about process. Some of it is the tooling and the technology, but a lot of this is how you educate your developers on security requirements, how you help your security team understand the rate of change that developers are moving at, and how you train up those teams to communicate more effectively. And those are things that are actually more OS agnostic. So I can't tell you may not run into hiccups, but what I can say is this is definitely possible no matter what OS, what environment you're running in.
Okay, great. Next question is from Brian, who asks, can you say something about web application firewalls? It's cons and pros. What is the best practice to integrate a web application firewall with DevOps or DevSecOps?
Yeah, so web application firewalls traditionally, and let me actually back up there. So web application firewall, there are known types of threats and attacks that a WAF protects from. You think about things like SQL injection, just to use a simple one. Those risks, those threats still exist. When you think about the role of a WAF in DevSecOps and shift left security in this modern world, the biggest challenge is how you attach what the WAF is filtering to a orchestrated or rapidly changing environment. If you are using something like Kubernetes or something to really scale a container deployment, the traditional notion of, well, I'm configuring a WAF by filtering traffic against these endpoints, that doesn't really work. And so is the role of a WAF from a protection standpoint still important? Yes, definitely. Those threats have not gone away. The challenge is traditional WAFs were built to be configured for traditional applications. And again, that's manually, and that's focused on endpoints and IP addresses and monolithic applications versus distributed microservice ones. The approach we've taken at Twistlock is to make the WAF service aware and container aware. So we're looking at what are the different services in your environment versus what are the different artifacts or IP endpoints, and then to automate enforcement and filtering of traffic. That's the approach I generally recommend taking. There are other approaches, and we're definitely not the only vendor out there with a sort of modern DevSecOps friendly WAF, but the traditional way of thinking about WAFs doesn't really apply in the DevSecOps world. You have to find a way to automate.
All right, great. Next question, Andre is asking, can you give us more information about your company's solution, please?
That's the type of question I always love hearing as a marketer. I will keep this very high level, and I'm more than happy if you want to reach out to me on LinkedIn, and my email address is up on the screen too. I'm more than happy to provide you more information via that channel. I'll keep this really high level. Twistlock, we're a cloud native cybersecurity platform. We automatically protect your applications against threats known and unknown. We have end-to-end compliance management and vulnerability management. And we offer layer 3 and layer 7 firewalls that are automatically deployed in your environment. And all that protection that we do is completely environment specific. Vulnerabilities are risk scored based on how they impact your specific environment. Firewalls are configured based on how you're deployed. Runtime protection is created based on how your applications are constructed. And it's whitelist based, so it's based on how they're run. There's a lot of protection and a lot of power, and our firm notion is with Twistlock, you can be more secure than you ever have been before. That's a bold statement, and I'll leave it there. Feel free to follow up with me for more information and some more technical details that I as a marketer just can't share.
Excellent, excellent. Okay, well that was actually the best question for us to close out the question and answer period. If we didn't get to your question, just know that Josh does get a copy of all of the questions, so I'm sure he or somebody else at Twistlock will be more than happy to follow up with you offline and answer any questions that you do have. And then as Josh noted, his email address is right there on the screen, so feel free to reach out to him directly. You can also follow them on Twitter and all those other lovely social media addresses. And also, just a reminder that if you missed any or all of today's event, you will be receiving a link post-event to access the webinar on demand. The webinar is also being posted on the devops.com website, so you feel free to take a look at the site to access this event. Also, feel free to take a look at the calendar of upcoming webinars that we have. And I do believe that the only thing I have left to say is a big thank you to Josh Thorngren, our speaker today. Thanks, Josh. I really had a great time listening to you, and I'm sure the audience got a lot out of it.
Thank you so much. Thanks for hosting, and thanks for everyone who attended as well.
Great, great. Well, thank you again, and thank you all for attending today's event. This is Charlene O'Hanlon, the moderator, and I'm signing off. Have a great day.